Hey guys, let's talk about this topic. Vectors are very important and easy topic only if you can visualize this. Alright, otherwise it's a little difficult because a lot of visualization is required. I'll help you with the help of technology here to understand and visualize this really easy. Alright, first of all, let's go ahead and try to understand the definition. And there's another law called as vector law of addition. We'll try to visualize this right now. Then we go ahead and learn other terminologies in this. Beautiful. Definition says this. Physical quantities having both magnitude and direction are called vectors. So what exactly is this? What are physical quantities? All those quantities which can be measured are physical quantities, and quantities like pain, emotions, love, patriotism, these are non-physical quantities. We cannot measure them at all, right? So now, these are physical quantities. For example, I have temperature and weight. With the help of these two, we can understand this definition really clearly, all right? Good enough. What exactly is temperature? Now, good example, guys. If at all I give you a thermometer and ask you to measure the temperature of your body, you would just take the thermometer, put it in your mouth. No direction is required. You can sleep, sit, north, east, west, whatever directions, you can still measure this, right? Completely. So these are called scalar quantities where we do not require any direction to measure the quantity, or they do not have that factor of direction. Now, for example, I have another machine, a weighing machine basically. I give this to you again and ask you to measure the weight, your weight basically. So the only possible way is you have to stand on it. Otherwise, you can't measure it. If you try this, that would be not advisable because you cannot measure the weight like that, can you? No. It means there is a direction required. Yes, of course. And let's suppose you are 60 kgs. So your weight is 60 kilograms, but acting in this direction. Can I represent this whole situation with help of some pictorial diagram? Of course, and that's exactly what is called a vector. So I can just draw a line like that. As I say, there is 1, 2, 3, 4, 5, 6. And the length of the line would tell it is 60 kgs. Okay. Every division here can be like 10 kgs. 10, 10, 10, 10, 10, and 10, of course. And this direction is telling in which direction I could measure this, or it is acting basically. Right. So that's how beautiful this, guys. Can I say how to represent 30 kgs? I can say, of course, another line which is, I can say 3 centimeters long, 1, 2, and 3. Well, that would be representing 30 kgs, right? Again, this length would say it is 30 kgs because I know that every division is 10 kgs. That's how beautiful it becomes to represent a physical quantity, which is a vector, in form of the line, or this is exactly what it is. And the length of this is called as the magnitude or the amplitude, and the direction, of course, right? We'll come back to how to calculate the direction and the magnitude a little later. Now, guys, we are very clear with this. Let's go ahead and try to understand what is vector law of addition. It's not important that those quantities which actually have direction and magnitude are always vectors. For example, if I have, let's say I have current flowing through two wires, 5 amperes and 4 amperes, and it comes out here, it has to be 9 amperes. We know that. It's pretty simple, right? Now, let's say this angle is, let's say, 40 degrees. Now, what if I change this angle, let's say 80 degrees, all right? And this is 5 amperes and 4 amperes again. Do you think that the current here would be different? No, it'll be 9 amps only. All right, let's try to understand the vector law of addition now with a graphic diagram. Let's go ahead, guys. All right, guys, to understand what exactly is a vector law of addition, look at that. We have a graphic diagram here. I'm taking the same things of 4 amperes here and 5 amperes of current, and I can see that if I change the angle here, it does not really matter. And we know that current actually flows in a particular direction. Even then, the sum of these two would not change if I change the angle between these two guys. So the direction of 4 ampere is changing, right, with respect to 5, but I can see the result is always 9. Now, what is vector law of addition? Now, look at this, the other example here. I can see a triangle here where AB is a vector, which is 5, and BC is again a vector, which is 3. Now, if I change the angle between them, look at that. The angle is 125 now, and I can see that the resultant of A and B, which is nothing but AC, right? We need to understand that if at all this is vector A and this is vector B, right? The displacement of the body from, let's say, the point A, B, and C, right? So the displacement of the body from A to C is given by this guy, and we call this to be vector A plus B, and this exactly is vector addition, right? Now I can see that depends on this angle here. If the angle changes, the length AC changes. It means this is following the vector law of addition, and I can see that example is not following. Look at that. I can change this. If I make it more like this, I can see the smaller the angle, then the AC is becoming small. So it means that AC depends on the angle between these two vectors, and definitely these are the quantities we call vectors, and those are the quantities where the angle between them is changing, even then the resultant is not differing basically, or it is not changing. We understand very clearly, guys, what exactly is vector law of addition. If at all I say that the sum or the sum of two vectors depend on the angle between its constituent elements, I say that is following the vector law of addition, and I can see in that case the angle between the two vectors 5 and 4 is changing, but the resultant is not changing. So we understand that they do not follow the vector law of addition. We cannot call current to be a vector, and we have to call this displacement quantity as a vector. That's it, guys. Let's go ahead and visualize vectors in more detail.